Okay. Bismillah ar-Rahman ar-Rahim. Now we'll continue doing this section in 9.3. So what we have, that was the last slide we did. And what we have in 9.3, let me just quickly remind you. We have the integral test. If the function is continuous and positive and decreasing, then the improper integral from 1 to infinity, and the series will do the same thing. They are converged. If one of them is converged, then the other one is converged. If one of them is diverged, then the other one diverge. And from that, we get what's called the P series, which is what? 1 over n to the power p. If p greater than 1, then this series converge. If p is less than 1, then this series diverge. Actually, it's more than between. Also, if p is negative, then this series will diverge too. Okay, that's what we have. So now we did all of these examples. Now let me do more examples. Okay. Yeah. First one. I have summation. 1 over n ln n square starting from 2. Because if start of 1, I have a problem here. So starting from 2. So let me call this is 1, 2, 3. So let me start with 1. What is my an? Let me, an f of n. That will be 1 over n ln n square. So I have my f of x. Oops. So I have my f of x equal 1 over n ln x square. Clear, this is positive and continuous for x greater than or equal to 2. Yeah. Now let's check decreasing. Let's check the decreasing case. I'll try to find f prime. What will be f prime at x? That will be 0 times derivative of that times the denominator. That's 0 minus 1 the numerator times the derivative denominator. This is the product rule. Let me do it carefully. That will be ln x square plus is the product rule. 2x ln x derivative of ln x, which is 1 over x, all over x square ln x to the power 4. Okay, and that will be negative. I can take ln x common factor. Yeah, this x instead with this x. Yeah, that make it ln x plus 2 over x square ln x to the power 4. Yeah, I can cancel this with this. This is in the power 3. No need. Then the denominator always positive for x. This is negative for x greater than or equal to 2. Very clear. Yeah. So it means f of x is decreasing. So all conditions of the integral, all the conditions of the integral test are satisfied. So now check. We need to do the integral from 2 to infinity. Or let me say here, conditions of integral test are satisfied or met. Okay, now we'll deal with the integral from 2 to infinity. 1 over x, then x all square dx. Yeah, I think this is easy to do. This will be what? Limit t goes to infinity, 2 to t dx over x, then x square. Yeah, if I let u ln x, then I have dx over dx. This will be my du. So I have u minus 2 du, which is, let me do it quickly, limit t goes to infinity. Yeah, you have u minus 2 du, which is minus u minus 1 plus c. So I need minus u, which is ln x to the power minus 1. Well, let me say 1 over ln x, make it easier. So I have minus 1 over ln x from 2 to t. Instead of doing changing t and changing these limits, yeah, I can do it quickly like this. And that will be limit as c goes to infinity, minus 1 over ln t plus 1 over ln 2. This is goes to 0. Ln infinity is infinity. 1 over infinity is 0. So this is goes to 0. So this is will be 1 over ln 2. Converges. So this is converge. That implies the series where n equal to infinity converges by the integral test. Okay, 2. I don't need the integral test in this case, where I have, this is what, summation n equal 1 to infinity, 3 over n to the power half. So this is a p series with p equal half less than 1. So diverges, which is a divergent p series. Number 3, this summation 2 to the power n over 3 to the power n, that will be 2 over 3 to the power n, which is what, geometric, with r equal to over 3 less than 1. So converge. Okay. Now let me move to the next one. Yeah, call it 4. This is 5. Okay. 4. I know this positive. Yeah, because tan inverse of x, for x greater than 1, it will be positive and continuous for x greater than equal to 1. And by the way, the same thing for this one. Secant, which is what? Summation in secant hyperbolic, 2 over e to the power x plus e minus x, which is positive and continuous for x greater than 1. So let's check the integral test. I need to check these two functions to be decreasing. Okay, let me do the first one. Or what is my f of x? 8 tan inverse of x over 1 plus x squared. What will be f prime? Yeah, be careful. I have 8 times 1 over 1 plus x squared times 1 plus x squared minus 2x 8 tan inverse of x all over 1 plus x squared all square. Okay, and that will be what? 8 minus 16x tan inverse of x. Tan inverse of x over this positive quantity. I can take 8, have 1 minus 2x tan inverse of x over 1 plus x squared all square. Yeah, I know that tan inverse of x is increasing function. Okay, so as x greater than 1, as x equal to 1, what will happen? I'm starting from 1, just to see it. It will be 8. That expression, let me say f of 1 will be 8. 1 minus 2, 1 tan inverse of 1, which is 5 by 4. So I have 1, yeah, over something, over 2 square. So I have what? 8 minus by, not 8. Yeah, 1 minus by over 2 over 4, which is negative. And if you have tan inverse of 2, tan inverse, yeah, for sure, this quantity will be bigger as we are going, as we are taking x equal 2, x equal 3, x equal 4. So this quantity always negative for x greater than or equal to 1. So the function is decreasing. So I can apply, and so yeah, we can apply the integral test. Conditions for the integral test satisfied. So integral 1 to infinity 8 tan inverse x over 1 plus x squared dx. Yeah. If I let you tan inverse of x, that will be du. So I have 8 limit t goes to infinity 1 to t. Yeah. Tan inverse of x dx over 1 plus x squared. This is my du. So I have u du. That will be, don't forget the 8, will not make a difference. That will be tan inverse of x squared over 2. Since I have u du, so it will be u squared, which is tan inverse of x from 1 to t. That will be 8 limit t goes to infinity tan inverse of 1, tan inverse of t over 2 minus tan inverse of 1, which is pi over 4 square over 2. The most important is this one. As t goes to infinity, this goes to pi over 2. And this is known about the tan inverse. So I'm getting a value. So it will be converge. What is the value? I don't care. That means it converge. So the series 8 tan inverse of n converges. Yeah. Let me give it more. Yeah. I think I will give more space for the next one. What is the next one? Number 5. Oops. Number 5. What's wrong? 5 summation n equal 1 to infinity secant hyperbolic n, which is summation. I think I work it out as an exponential function. Will be easier. Okay. I know it's positive and continuous, so I need to check the decreasing. So I have f of x secant hyperbolic x, which is 2 a to the power x plus e minus x. What will be f prime? F prime will be, yeah, minus derivative of 2, 0. So it will be minus derivative minus 2 derivative denominator, which is e to the power x minus e minus x, all e to the power x plus e minus x all square. I know that e to the power x always greater than e to the minus x for x greater than or equal to 1. So this is a negative. So f is decreasing. Yeah, for x greater than 1. Okay, so apply integral test. What you will get integral from 1 to infinity of secant x, secant hyperbolic x, integral 1 to infinity 2 over e to the power x plus e minus x dx. How to do this integral? Yeah, multiply by e to the power x in both in numerator and denominator. I have 2 e to the power x over e to the power 2x plus 1. Now, yeah, this is the limit. T goes to infinity. 1 to t, 2 e to the power x dx over e to x plus 1. So I let u equal e to the power x. So du e to the power x dx. So this integral, call it I. So I will be what? Yeah, limit as t goes to infinity of what? This is du, so you have 2 du over u squared plus 1. From where to where? E to e to the power t. Okay. And that is what? Limit t goes to infinity. This is 2 tan inverse u from e to e to the power t. So that will be what? Yeah. This is t will be e to the power x, sorry. That will be e to the power x. So I have x goes to infinity. Yeah. Let u equal e to the power x. Okay. Yeah. That will be 2 tan inverse limit. Don't forget the limit. Limit t goes to infinity. 2 tan inverse e to the power t minus 2 tan inverse a. I don't care what this is, just a number. This one, it will happen as t goes to infinity. Et goes to infinity. So tan inverse of et goes to pi over 2. So this is a number. This is a number. So this is converge. So the series secant hyperbolic n converges by the integral test. That is what they did. Converge by the integral test, and not with this one, converge by the integral test. Let me see just few number of all the exams questions, just to finish the section. Okay, let me do them quickly. Which one of the following series is convergent? Notice all of them, they are P series. This is P series, all of them. P series. This is P equal 3 over 4, less than 1, diverge. P equal pi, greater than 1, converge. P equal pi minus 3, which is what? 3.14 minus 3, that will be less than 1, diverge. P equal 2 over 3, less than 1, diverge. This one, I can rewrite it in equal to infinity, 1 over n to the power minus 3. So P equal minus 3, less than 1, diverge. So that's the only one. 1 over n ln n all square, I think we did. Yeah, it was the first one, and it was converging. The converge by integral test. No need to do it again. Using the integral test, when this series will converge. He said using the integral test. So halas, the conditions from the integral test, at least my understanding from the question, already met. So now I need to check the integral. So we'll do the integral 1 to infinity n 1 plus n squared to the power b x squared dx. This is what I need to do. I need to do this integral. So I have 2.5. So that will be half limit t goes to infinity of what? Yeah, 1 to t, 1 to t Yeah. You know what? Let me do this integral as indefinite integral, and then I plug it. I think this will be easier. This is 2. This is half. That will be half u to the power p du, where u is 1 plus x squared. So du is 2x dx. That will be half u to the power p plus 1 over p plus 1. So no need for the integral. I have u, which is what? 1 plus x squared. 1 plus x squared to the power p plus 1 over p plus 1 from 1 to t. Yeah, from 1 to t. So that will be half limit t goes to infinity of this expression. 1 plus x squared, 1 plus x squared, all to the power t plus 1 over 1 plus t squared, what I'm doing, p plus 1 over p plus 1 minus 2 to the power p plus 1 over p plus 1. This is just a number, so that will not affect the convergence. What will affect the convergence? This power, because this is go to infinity. So this will converge if the power is negative, i.e. if b less than minus 1. If b less than minus 1. And that will be my answer. Okay. This one, this series. Yeah. So I need to check the conditions. This is positive, very clear. Continuous, very clear. Now let me check f prime x over ax squared. What will be f prime of x? It will be ax squared minus x times 2x ax squared over x squared squared. So I can take e to the power x squared common factor, cancel it with the denominator. So you have 1 minus 2x over this. And this is negative for x greater than or equal to 1. Very clear, this will be negative. Okay, so decreasing. So now we can apply the integral test. Find the integral from 1 to infinity, x over ax squared dx. Yeah. Let me do the integral here. That will be x dx. That will be 2, and this is half. So that will be half e. I let u equal x squared. So du equal to x dx. So I have e 1 over du over e to the power u. In other words, e is minus u du, which is minus half e is minus u plus c. So this is with the limit at t goes to infinity, 1 to t. That will be limit as t goes to infinity, minus half e minus u, what is u? X squared from 1 to t. That will be limit t goes to infinity, minus half e minus t squared minus or plus half e is minus 1. What I care about only this, not as t goes to infinity, e is minus t squared, this goes to 0. So I have half e is minus 1 converges. So the series converges. Yeah. And I just need to check this one. Okay. X equal to this one. I have this example meaning the series converge or diverge. Okay. Now this is positive and continuous. Very clear. So check now the being decreasing or not. 1 over, it should be decreasing. Yeah. 1 plus then x all square. And in f prime, to check the conditions, f prime will be what? Yeah. The derivative of 1 is 0, so I need just only minus 1 times the derivative of the denominator, which is x, so it will be 1 plus then x all square plus x times what? Derivative of this, which is 2 then x times 1 over x all over x square 1 plus x all square. Here, all square. Okay. This is for sure less than 0 for x greater than or equal to 1. Yeah, this is cancelled. So numerator is positive times minus 1, which is negative, and the denominator all is positive. So this is distance here, so decreasing. So the conditions for the integral test are met. Okay. Now do the integral 1 to infinity of this all square dx. As usual, this will be the limit at t goes to infinity, 1 to t. Let me do the integration as a definite one, as indefinite, I mean, to avoid writing this and that. Y equal to x, u equal to n x, du equal dx over x. So I have what integral du over 1 plus u square. And that will be tan inverse of u, tan inverse of ln x plus c. So this one will be, give it more space, limit. This is just a note, huh? Limit t goes to infinity of what? It's tan inverse of ln x from 1 to t. And that will be limit t goes to infinity, tan inverse of ln x. Ln 1 is 0, tan inverse of 0, 0, gone, and this will be pi over 2. Since as t goes to infinity, this is t, sorry. Yeah, this is t. Substitute the t. At t goes to infinity, then t goes to infinity, tan inverse infinity is pi over 2. Converges. So the series converge by the integral test. Okay. In applying the integral test. Okay. I think now we mentioned that integral test. So let us do it right away. The integral 1 to infinity. I'm assuming the conditions are met since he said we applied the integral test. So the conditions should be met. So 4n for x over x squared plus 1 all squared dx. I need to do this, which is the limit as t goes to infinity, 1 to t for x over x squared plus 1 squared dx. Let me do this as indefinite integral. This 4, I'll make it 2. I let u equal x squared plus 1. So du equal to x dx. That will be 2 du over u squared, which is u to the power minus 2 du to save time. which is minus 2 over u plus c. So I have this limit t goes to infinity minus 2 over u is what? X squared plus 1 from 1 to t. And that will be limit t goes to infinity minus 2 over t squared plus 1 minus plus minus, that will be 2 over 2. Okay. And this goes to 0 as t goes to infinity. So I have 1. And so the series, I have convergence. Not only that. So I have the summation. It's not only the integral converge, also the summation converge. Is its thumb is 1? No, nothing like that. No relation at all. So we say the series is convergent, and this is the correct answer. And the integral test, is it applicable or not? Yes, we can check that. Yeah, since he said that. I know this is positive and continuous. So let me check this condition that the integral test is applicable. I forgot to say that. So I need to check f of x for x over x squared plus 1 square. What will be f prime? That will be, let me give it more space. I need to check if f prime is negative. So I have 4 times this minus 4x times 2 times x squared plus 1 times 2x all over x squared plus 1 to the power 4. Now let me take x squared plus 1 as a common factor. What's the remaining? 4 x squared plus 1. I have what? Take x squared plus 1 minus 16 x squared over this. This will be 3. This is cancelled. So I have 4 minus 15 x squared over this. And this is negative for x greater than or equal to 1. Very clear. So decreasing. And so decreasing. So this is wrong. Integral test is applicable. Okay. I have 2 to go. So these are just examples from the old exams. Yeah. This one is positive and continuous. Starting from 1, I have no problems at all. Check f prime. I have f of x is 1 over square root of x plus 1. What will be f prime? Yeah, be careful. Minus derivative of the denominator, 1 over 2 root x times root x plus 1 plus root x times 1 over 2 root x over root x whole square. This is positive. The things inside the bracket is also positive. For x greater than 1, we're talking here for x greater than or equal to 1 is less than 0. So f is decreasing. And we can apply now the integral test. Let me do the integral on infinity 1 square root of x square root of x plus 1. Okay, that will not make a difference. I have 1 over. Yeah, that will not make a difference about the conclusion. This is also negative. Dx. Yeah. I need to do this one now. I need to do this integral. So that will be limit t goes to infinity 1 to t dx over square root of x plus 1. Okay. So let me do the indefinite integral just to save time. I let you to be what? Yeah. How to do that as an integral? Yeah, the integral, how to do this? Square root of x is square root of x plus 1. So if I take this one is square root of x plus 1, what will be du? It will be 1 over 2 root x plus 1 dx. Okay, but I don't have that here. How to do this integral easily? If I let u square root of x, let me see what will happen. If I let u square root of x, that means u square will be x, and 2u du will be dx. So I have what? Integral, yeah, 2u du over u. This is x is u square, square root u square plus 1. Square root u square plus 1. Okay. 2u du. U equals square root of x. U square is equal to x. 2u du is equal to x. Okay. So dx du 2u du, that will be u. And this is square root u square plus 1. Great. So you cancelled with u. So you have integral 2 du over square root u square plus 1. So now I let u to be what? Tan theta. Okay. Let me see what will happen. If u equal tan theta, du will be secant square theta d theta. Yeah, so that will be integral 2 secant square theta d theta. Okay, over square root tan square plus 1, that is secant square, that will be secant. And that will be integral 2 secant theta d theta, which is 2 ln secant plus tan plus c. And what is secant? U, this is the triangle, u1 square root 1 plus u square. So that will be ln, what is secant? Secant square root 1 plus u square, which is square root 1 plus u square. Yeah. Okay. And tan is u plus c. What is u? U square is x, and u square root of x plus c. Okay. So that will be limit t goes to infinity. Okay. Of what? Ln 1 plus square root of x plus square root of x. No, it is square root. Yeah. 1 plus x. Yeah. From 1 to t. And that will be limit t goes to infinity. Ln square root 1 plus t plus square root of t minus with 1 square root of 1 plus 1, that's square root of 2 plus 1 minus ln a number which is 1 plus square root of 2. Okay. Now this thing goes to what? As t goes to infinity. This goes to infinity. Where square root of infinity, infinity plus infinity, ln of infinity goes to infinity. So diverge. So the series diverges by the integral test. Yeah, let me do this problem. Which of the following solution is true about the series? One of them, the integral test cannot be applied. No, so we need to check everything. Now this one is positive and continuous. I need to check the being decreasing. I have x over x squared plus 1. What will be f prime? Yeah, f prime will be x squared plus 1 minus x times 2x all over x squared plus 1 all square. And that is 1 minus, I have 2x squared plus x squared. That will be minus x squared. Well, this is negative for x greater than 1. Okay. Yeah. So I need to check down the integral from 1 to infinity. X over x squared plus 1 dx is very clear. This is 2. This is half. This is u du. We have half. This is u. That du, that will be then x squared plus 1 from 1 to t. Yeah, can do it quickly. That will be half ln t squared plus 1 minus half ln 2. I need the limit. Don't forget the limit. T goes to infinity. That give me what? As t goes to infinity, this is infinity, then infinity, infinity. So this is diverges. Diverges. So the series diverges too. Yeah, I think that will be good number of examples to explain this integral test. The integral test is, I have the B series, 1 over n to the power b, which is easy one, and the integral test where I need to compare the proper integral with the converges. If the proper integral converge, then the series converge. If the proper integral diverge, then the series diverge, provided that the function is continuous, positive, and decreasing. And I did examples, just examples, different examples, and yeah, I did not cover most of the old exams questions because after I finish 9.6, I will do exercises where I don't know which method I shall use. So I will do different exercises covering all the methods in 9.3 up to 9.6. So let me stop now the recording for this video. So now I finish 9.3 as basic videos, and then after I finish 9.6, I will go back to all of these 4 sections doing some old exams problems where I don't know which method I shall use. Okay. Thank you.